Okay, hello Cloud Gurus and welcome to this lecture. This lecture we're going to look at SQS, and as you might remember from the history section of the course, SQS was one of the very first AWS services. In fact, it was the first AWS service. And for that reason, it's got a lot of legacy and it can definitely appear in your exam. So what is SQS? So why don't we start with the Amazon definition. So Amazon SQS is a web service that gives you access to a message queue that can be used to store messages while waiting for a computer to process them. So that's all it is. It's a way of storing messages while you're waiting for a computer to go and process that message. And SQS is a distributed queue system that enables web service applications to quickly and reliably queue messages that one component in the application generates to be consumed by another component. A queue is a temporary repository for messages that are awaiting processing. So essentially you've got a server, it creates a message, that message is stored in an SQS queue and it's waiting for another server to go in and process that message. That's all SQS is. And if that still doesn't make a lot of sense, let's have a look at a couple of examples. So let's say we've got a meme website. We've got our user and they want to go ahead and create a meme. And let's say they upload a file to an S3 bucket that our website is using. And this is a picture of the A Cloud Guru team in Melbourne. Let's say they want to create a meme out of that. As soon as they upload that file to an S3 bucket, it triggers a Lambda function. And we're going to cover off what Lambda is in the very next section of the course. But let's just say that it triggers a Lambda function. And that Lambda function is just basically a piece of programming that does something with this image. What that Lambda function does is it goes and stores information in SQS. So it's going to store what caption that they want to write across this meme. It's also going to store the location of this image in the S3 bucket. And that's all stored in a message in SQS. We then have a fleet of EC2 instances. Now these can also be behind an auto-scaling group, or it could just be 2 or 3 or even just one EC2 instance. And basically the EC2 instances poll the SQS queue looking for messages. And when they get a message, they basically take that message from the SQS queue and then they go ahead and create the meme. And let's say they store that meme into S3. So it looked like something like this. Hello, Cloud Gurus. That is then stored in S3. Now, if we were to lose our EC2 instance or a fleet of EC2 instances, the messages are still held in the SQS queue and another EC2 instance can come along and process them. Another example of an SQS website would be a travel website. So let's say we've got our user and they want to book a holiday. Let's say it's with Expedia or with Skyscanner. Big shout out to both those companies because I use them all the time. So our user is basically, they put a query into our web servers and they say, hey, I want to go to Cancun for these 2 weeks. And they enter in the date. And then basically what that EC2 instance does is it takes what the user is requesting and it stores it in an SQS queue. We then have a fleet of EC2 web servers and they are polling that queue and they're looking for that SQS message. And then what they do is they go out and query all the different airline servers saying, hey, how much is a flight from Cancun on these dates? So they might poll American Airways, or they might poll Delta, or they might poll Virgin Atlantic, or wherever. And basically they then take that information and then they send that information back to the web server who sends it back to the user. So that's another good example of using SQS. Using Amazon SQS, you can decouple the components of your application so that they run independently, easing message management between components. And any component of a distributed application can store messages in a fail-safe queue. And messages can contain up to 256 kilobytes of text in any format. Any component can later retrieve the messages programmatically using the Amazon SQS API. Now, this 256 kilobytes of text is contained within the SQS queue itself. If you need to go over that, you can. You can currently go up to, I think it's 2 gigabytes in size, and those messages are then stored on S3, but SQS is still able to access that. But most people, 256 kilobytes of text is enough, and that's all stored on SQS. So the queue acts as a buffer between the components producing and saving data and the components receiving the data for processing. And this means that the queue resolves issues that arise if the producer is producing work faster than the consumer can process it, or if the producer or consumer are only intermittently connected to the network. So you can actually go in and set up auto-scaling groups, and you can have a trigger as to how many messages are in the queue. And if the number of messages goes over 5 or 100 or 1,000, that can trigger an auto-scaling event. So there's two different types of queues with SQS. We have our standard queues, which are our queues by default, and then we have our FIFO queues, so first in, first out queues. So SQS standard is the default queue type, and a standard queue lets you have nearly unlimited number of transactions per second, and standard queues guarantee that a message is delivered at least once. However, occasionally, because of the highly distributed architecture that allows high throughput, more than one copy of a message might be delivered out of order. Standard queues provide best effort ordering, which ensures that the messages are generally delivered in the same order that they are sent. So it's generally in the same order that they're sent, but there's no promises. And remember that messages can be delivered more than once. So the FIFO queue complements the standard queue, and the most important features of this queue is that they're first in, first out. So they are definitely ordered, and you'll get exactly one-time processing. So the order in which the messages are sent and received is strictly preserved, and a message is delivered once and it remains available until the consumer processes and deletes it. Duplicates are not introduced into the queue. So if you need to have order in your queue and you don't want to have any duplicates, you want FIFO. If that doesn't matter, if your application can have duplicates and you're not too concerned about how often messages are delivered and in what order, then you can go ahead and just use standard. And you're going to be quizzed on this in your exam. Remember that FIFO queues also support message groups that allow multiple ordered message groups within a single queue. So FIFO queues are limited to 300 transactions per second, but they have all the same capabilities of a standard queue. So that's it for SQS. You just need to understand what it is at a high level. Just remember my exam tips. SQS is always going to be pull-based. It's not push-based. So you've got your EC2 instances. They're going in there and they're pulling messages down from the queue. SQS is not pushing the messages out to your EC2 instances. If you need anything that's push-based, we're going to be using SNS, and we'll look at that later on in this section of the course. Messages are 256 kilobytes in size when you're using SQS. You can go up to 2 gigs, but you're going to need to be using S3 for that. So messages are always 256 kilobytes in size. And messages can be kept in the queue from 1 minute to 14 days, and the default retention period is 4 days. Also remember that the visibility timeout, and the visibility timeout is the amount of time that messages are invisible in the SQS queue after a reader picks up that message. So let's say we've got our meme website and we send that message off to our SQS queue. Our EC2 instance will pick that message up, and that will basically make that message invisible to other EC2 instances. But that message will time out unless that EC2 instance goes in and deletes that message. And when it times out, it becomes visible again. And the thing about this is it stops your EC2 instances from, if they die, you know that the message is still in the queue. It will hit the visibility timeout period. It will become visible again. And then another EC2 instance will come in and read that message. Now, provided the job is processed before the visibility timeout expires, the message will then be deleted from the queue. And if the job doesn't process within that time frame, the message will become visible again and another reader will process it. And this could result in the same message being delivered twice. And the visibility timeout maximum is 12 hours. So your EC2 instance has 12 hours in which to process SQS messages. Also remember going into your exam that SQS guarantees that your messages will be processed at least once. And SQS long polling is a way to retrieve messages from your Amazon SQS queue. So while the regular short polling returns messages immediately, even if the message queue being polled is empty, long polling doesn't return a response until the message arrives in the message queue or the long poll times out. So essentially, this is a way of saving money. You don't have your EC2 instances constantly polling an empty SQS pool. What you do is you turn on long polling, and then that will save you some money. Long polling won't return a response until a message arrives in the message queue value or the long pole times out. So that is it for this lecture, everyone. If you have any questions, please let me know. We're not going to do anything hands-on with SQS in this course. You just basically need to know what SQS is and the different queue types. So you've got standard and then FIFO, and then just understand its use case. It's a way of decoupling your tightly coupled infrastructure. If you do want to learn more about SQS, definitely check out the AWS documentation. So if you've got any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.